Hey people, going live a little bit early again today. So early birds, they they get to chat a little bit before we do the interesting stuff. And this stream should be interesting, and maybe not as interesting as last week, because that was like the definitive smoke stream. But I think we're gonna do some interesting tests today. See how they go, and might make things easier. So let's see here. There's a lot of people saying first and then their message getting deleted. I don't know, man. That's YouTube. Let's turn this away. We do that. Now it's on me. That's not good either. There we go. Okay, this music goes to here. Okay, so how's everyone's weekend starting off? Hey? First lost, who cares? So Killer Geek is here, and Remco Maase, C-Sharp Worm, hey, caught a live stream. It's kind of most of the time on the same day around the same time, but time to make a coffee, says Dave. Music is rocking, oh yeah. Oh, Bart says, hi neighbor, greetings from Belgium. Today we're drinking, it's a Spa Red. It's no Coke today. Guess I lost my sponsorship, eh? I wish there was a sponsorship to lose there. Anyway, my real job's driving me nuts. Well, then you can listen to me. I don't know if that's going to make things better, but I don't know. Oh, C-Sharp Herb is also supposed to be working. Whoa, Jordan Rail says, hey, hi, starting good. Just signed to do R&D for a major stage lighting distributor manufacturer. I can't even say those words. Greetings from France. First time watching live. Cool. Welcome. Oh, and Netwise is from Belgium too. Nice. Time for our weekly dose of Quindor. Well, I do try to release at least a video or a live stream once a week, and mostly on Fridays. So, yeah. Got to keep you guys hooked. Greetings from Berlicum. Could almost hear your music with the windows open. It's not that loud. It's like inside my headphones. That's why I wear the headphones. But oh, we have a Belgium 3. I wonder how many Belgian people we have here. Greetings from San Francisco. Nice. I've been to San Francisco once. I was there a few hours. We drove through it, basically. Hello from Poland. Cool. So, what are you guys planning this weekend? I'm taking the girlfriend out to dinner tomorrow, so that's nice. Well, it's nice that we can do that again. And yeah, not much else. What are you guys planning for this weekend? Are you allowed to do stuff yet because of COVID, or still locked at home? Very curious to see how efficient 24 volt to 5 volt does. I am too. Let's turn this off. There we go. Oh, Dave Menkhorst is on vacation, but it's Smoky Friday with Quindor tonight. I don't know if we'll get smoke. Maybe. I'm not saying we won't get smoke, but who knows? Oh, planning on working on your X-Lite setup for Halloween. Nice. Oh, Jeff's system is actually 24 volt to 12 volt, and he's been happy with it. Cool. But Jeff, do you have like multiple of these converters hooked up, or are you only using one? Or if you are using multiple, do you then have plus just connected everywhere, or do you have a disconnect in it? Those are some questions I have about this type of setup, actually. And, well, let's see if we can answer a few of those today. But, yeah. Wivum is technically BE, but he's now in FI, Finland. Hack on my WLED effect visualization images. Oh, Phil is here. Phil Bulldog. Cool. Multiple of those small black converters. One at the front, one in the middle, and one at the end. Okay. But is all plus lines connected, or are they disconnected somehow? I imagine you have them all connected. That's what I'm hoping will work okay. But yeah. I have a new tool out today. I bought it a while back, and I didn't think about it in last stream, but we're actually going to be using a clamp meter to also measure the amps next to measuring what's coming from the socket. Actually, I need to zero it. Actually, I need to turn it off because it's not doing anything right now. But more about that later, once we've officially started. All connected. Okay. Yeah, that's what I'm interested in, seeing how that will do. How's the audio? Am I loud enough? I'm thinking I might be a little bit soft, but let me know. Take a sip of my non-Coke here today. Brian Wallow says, when my wife hears me listening to your stream, okay, video, she always said, "Are you hanging out with that Quinn guy again?" It's that darn Quinn guy. He's always interrupting our us time. Audio's good on my end, plenty loud. Sounds good to me. Yeah, you're good. Audio's fine. Okay. Thank you very much. Cool. Yeah, so I take you away from the wife, huh? Sometimes a little bit of time away from the wife is good. Not too much. That's why I'm taking mine to dinner tomorrow. Because, you know, sometimes you have to plan time together. That's a good thing. Cool. So how many people are here right now? 58. Oh, it's a slow night tonight. Well, we haven't officially started yet, but yeah. Damn Quinn guy always makes me spend money on tech gear. Dinner in the Netherlands is like one of those things out of the wall, right? No, you take her to like a nice restaurant, or at least a restaurant we both like, and then you sit down and you have food. Not something out of the wall. What are you talking about? Dave Manko says, "You're a pro, Quindor. Learned a lot from you." Thank you very much. Frikandelletje uit de muur. No, I like this girl, you know, so I'd like to keep her. I'm not sure if Frikandelletje uit de muur is a very good gesture of affection. I don't know. Maybe. It depends on the girl, I guess. I'm not sure mine would like it too much. But, yeah. Anyway. Yeah, so we have plenty of meters here today. And lots of wires. I actually didn't clean up the session from last time yet. Because I thought, like, we're going to do a lot of the same stuff today. So, I got my coffee. You can start now. Discorded you some images of my 24 volt project box. Cool. 800 pixels, really not pulling much. Yeah. On average, it wouldn't be too much. Let me take a look. Ah. A nice Meanwell power supply. You got a relay in there. Cool. And then a distribution panel with some fuses. Nice. Oh wow, you even have some meters showing all the loads. Cool. Yeah, that's cool. I'm not going to show it on stream right now, but... Any plans to put a USB-C mini connector on your QuinLED boards for power? You mean like for the 5 volt EXT, or you mean a separate board which you can power over USB? What are we talking about? Circuit breakers, not fuses. Ah, okay. Cool. Dutch food culture is strange. No, we have restaurants and stuff like that too. I mean, I guess. Let me see if I can find it. Let me see if I can find it. I think I will be able to find it. Yeah. I actually didn't have a secret to share today, but I might. If we have a good live stream, I'll share something I've actually been working on for quite a while, which hasn't been released yet for various reasons. But yeah. Sprinkles on bread. WTF. What? No, sprinkles on bread is good. Okay, so we're at a quarter past 9, which is the official starting time. So let's talk about what we're going to do today. And Ethernet DIY board. What do you mean Ethernet DIY board? You can already do Ethernet with the DIY board. Currently there's some limitations though. But there will be updates to that board at some point so that the DIY doesn't have most of those limitations like the pre-assembled doesn't have now either. Ah, yeah. Okay, Craig. You'll have to wait until the end of the stream. I'll share something I've actually been working on for over a year now. And technically it's done, but there's other issues preventing it from coming out. But stay watching. Yes. And the secret is always later. Hey, come on. So anyway, today we're going to take a look at doing a 5 volt addressable LED setup, but then using 24 volt to distribute the power, because 5 volt is nice, is great because it doesn't use a lot of power. It's very efficient, and it's single LED addressable. If you step up to 12 volt, you often end up with per 3 LEDs addressable, and 12 volt will allow you to use shorter cables. As I said, it has its per 3 addressable downside, or if you have WS2815, you have the downside that it is per LED addressable, but then it wastes a lot of power because it still needs to step down from 12 volt to 3 volt, about which the LED is. So basically a lot of power is burned off blindly. And I was like, okay, but what if we wanted to use 24 volt? Because the current pre-assembled boards all support 24 volt. So we could still use our Dig-Uno and Dig-Quad to do all the level shifting and all the ports and the terminals and fusing and stuff like that, power distribution, because it'll take 24 volt in, regulate that to whatever the ESP and other stuff needs, and then output 24 volt again. But then I mean, we'll be doing a 24 volt LED episode in the future. I have already one strip in, and I ordered another one yesterday. But 24 volt addressable LED strip has the downside that it's per 6 addressable. So now if you have a meter with 60 LEDs per meter, that means you only have 10 addressable zones. But what if we could use 24 volt power for the transport, for the power injection and stuff like that, but then use 5 volt strip? Well, that's, I'm going to remove this giant thing here. That's where these guys come in. Late to the party, that's okay, Philip, that's okay. So these are DC-DC converters. Go away, QuinLED. And these all output 5 volt. So let's put them in order of size. Yeah, this one's a bit chunky. So first off, we have this tiny little one, which says it'll do 5 volt and 5 amp output and 12 to 24 volt in. Okay. Is that zoom? Is that focused okay? Let's focus that again. There we go. Then we have this one, which also says it'll do 5 volt and 5 amp out with 24 volt input. But then we have this one, and it'll do 10 amp output, 5 volt. And then we have a chunky boy here, which says it'll do 5 volt, 15 amp. Now, these values aren't chosen arbitrarily. 5 amp is generally what you need if you have a single injection point at an edge of an LED strip. So if you imagine like 10 meters of LED strip and you inject the front, the middle, and the end, a single injection point at an end somewhere generally doesn't use more than 3 to maybe 4 or 5 amps. So that's why I have those 5 amp converters. But in the middle, power can travel both ways, so you'll need to double that up basically. And there, the 10 amp or the 15 amp, this chunky boy here, might be needed. I don't know. But first, let's figure out if we can actually do this. I mean, let's take 10 meters of cable, so 32 feet. Let's run it in the 5 volt setup, see how that does. And then let's run it in the 24 volt and step down setup. Because if we use 18 gauge cable, are we going to get a lot of voltage drop? Well, let's see. We can actually calculate that. Yeah, and then, yeah. So let's say we have 18 gauge. We're going to run that for 10 meters. And we're going to do that at 5 volt. And we're going to need about 6 amps because we're going to use one of my LED load bars, and that takes in 6 amps. Okay, if we try to push 5 volts through 10 meters of 18 gauge, we'll end up with 2.5 volt at the end. So 2.5 volt or 50% will almost have been burned off just running the power through the cable. And then the LEDs will get 2.5 volts. So don't use linear step downs. No, these are all buck converters. Linear would just burn off the power. That'd be very inefficient. But yeah, so if we do this with 5 volt, that's likely not going to work very well. We're going to test that. We're going to measure what it does with the short cables. Then we'll attach the long cables with 5 volt, see what we actually get. And then we're going to replace that with a 24 volt setup. Because if we change this from 5 volt to 24 volt, we get about 10% drop. We still drop the same amount of voltage, but since we're inputting 24 volt and we're ending up with, well, 21.5, 22 volt, that's fine, because this thing takes anything from, I believe, 10 volt to 30 volt and converts it to 5 volt. So yes, we'll still be losing some power in the cable, but it shouldn't affect the LEDs. And now we should be able to use much thinner cable. So let's say we go to 22 gauge. Sure, that's a 26% drop or 6 volts, but it still wouldn't affect the LEDs. The cable might get a bit hotter, but you know, there's always trade-offs. But at least you don't need a very thick cable, because if we wanted to stay within that 10% for 5 volt, let's see, what do we need to get 10%? Well, even 12 gauge isn't enough. Wow. So 12 gauge is hold on. 12 gauge is this giant thick cable here, and even running 10 meters of that would still give me 12% voltage drop if I wanted to draw 6 amp, which is just one of my LED load bars. And in comparison, this is the 18 gauge I want to use. As you can see, that's much smaller, but using 24 volt on this one versus 5 volt on this one should in theory still be more efficient on this one. So you can use much thinner cable and prevent a lot of the issues. Oh right, I don't Philip, you're right. I'm being an idiot. Philip's right. Guys, if you're ever in the Discord, listen to Philip, because he even spots my mistakes. He's right. If we're doing 24 volt, we don't need 6 amps anymore, because we're converting from 24 to 5, so we're dropping it down, and well, let's say we only need, wait, let's put this back to 18. So, yeah, let's say we need 2 amps, we're only going to be losing like 3 to 4%, because we're down converting, so 1 amp at 24 volts is 24 watts, so 24 watts divided by 5 volt is not 1 amp, but about 2.5. That makes sense to you. So easiest is always to calculate the watts, because for watts the voltage doesn't matter, and then you can then calculate the amperage for the voltage you want to run. So that's very correct, Philip. I forgot that step. So running, I mean, we could even probably run like 24 gauge. Let's see, with 24 gauge 2 amp. Oh, okay, that's maybe mid, but 22 gauge. Yeah, even with 22 gauge wire, and I have that here. Let's see, what is this? No. Yeah, so, okay. So, in theory, instead of running 10 meters of this, we could run, and see if I find an end here. No. Well, I think it's obvious. We could run 10 meters of this stuff, which is a lot thinner, and still have a better result. In the UK, we have a problem with the new tech like LEDs. We have to put do not insulation test these circuits. Okay. Anyway, so yeah, this cable is of course way more expensive than this cable, but then again, you have the expense for the converters. So we'll figure out later what that comes down to. Okay. So first we need a baseline and figure out 2 or 3 settings we're going to do on these LEDs, and then measure the power. And last time you saw me using the external meter in the AC socket, and well, some people asked, yeah, but how much are you losing because of the power supply and stuff like that? Well, I guess let's see. Okay, so I zeroed this meter. One of the LED load bars is connected with about 143 SK6812 RGBW LEDs. And we're still using that Meanwell power supply we looked at you last time and stuff like that. So, okay, WLED is turned on, and currently the meter on the socket is displaying 9.3 watts. And we're seeing about 1 amp here. So this is about 5 watt, and the power supply is using about 10 watt. But that's normal. The power supply also has its idle currents and stuff like that. But let's pick a few values and let's write down what that does. So let's see. Let's pick 100% orange, and I'm going to open a notepad for myself. Because then we'll also have an idea of what the converters are being actually asked to do. So, orange 100%. No, let me... does that work? Does this still work? Okay. 5 volt short wire setup, right? Orange is using, and let me then say socket meter. Just, 13.75 watts, and this is 1.7 amps. Let me look at chat for a minute. Sound here is fine. Sounds perfect. Sound is out. Oh. Oh no. Okay. He thinks his headset's screwed up. Yeah, the converter module is just a buck converter, so it'll have some efficiency losses, like 10, maybe 15%. We'll have to see. So currently with 100% orange, we're doing, well, what's on screen here. Let's replace that with blue, because that's a single color. Blue, that does 11.89 watts from the socket, or 1.4 amps. So those all aren't very taxing, but as soon as I hit white, and you'll remember that from last time, we're now drawing white 100%. 37.56 from the watts and 6.15 from the meter. And then for fun, I don't know if you can see the LED, but let me show you the LED for a little bit. Why is this so big? Uh-oh. I always have to mess with it. There, now you can see what's on the bar. Let me change this to an effect, and let's go to Pride 2015, for instance. Yeah, it still won't show up on camera, but Pride 2015, Pride 100%. And that is using, oh, it's of course a bit varying. About 8 watt from the socket and well, it depends on what you have set for the white setting. In this case, I have it set to dual, so it'll use RGBW all at the same time, drawing an insane amount of power. Okay, so we're about at, let's say, 0.8 amps on the meter. And let's try one more effect. Yeah, what should it be? Flow. Flow's a good one. Flow is 12.04 watt and 1.4, let's say 1.4 amps. Sure. Let me save this real quick. Okay, so now we have a sort of baseline of what this one of these bars uses. Well, using 5 volt and measured with the amp meter and on the socket. As you can see, as it goes up, the variance between those two actually decreases. So especially if you look at the 37.56 watts, if we do 615 times 5, that's about 6 or 7 watts above what the amp meter is showing. So yeah, using AC measurements is less secure in that regard, but it does add some padding to the numbers. But we'll do both this time. That's fine. Oh, right. Yeah, I don't know why I actually changed between those two, but yeah. Yes, correct. So these are indeed 4 times 255. That's why it draws such an insane amount of power. Right. So these are about 50 centimeter wires to the LED strip itself, and they're 18 gauge, so they don't really lose that much power over that distance. But we're now going to be switching to these wires. So these are also 18 gauge. These are actually the same as are connected to the LED strip right now. Let me turn this off. And but these are of course much longer. Now I have 2 bundles of this, and we'll be using one for power and one for the amount of loss on the cable will go up. Right. So why is there still a wire end I can see? Okay, it's just a little loose piece of wire. Right. So okay, let's splice these in there, and I'm gonna route these like that. Oh, let's disconnect that. Right. So let's disconnect these. The stream is stopping. Uh-oh. Let me check if I add some lost frames here. Nope. Says I have 0 lost frames on anything. No drops, no network drops, no rendering lag. Interesting. I guess YouTube is on the fritz, huh? Okay, so everything's back right now. That's not good. Right, so we're hooking up the 10 meter power cable right now. Cool, okay. Okay, and well, that's why I have the second set of wires here, but let me do this first. So this is the other end, and I'm going to take one of these blocks, because these should fit in here. They do. Because then we can hook up the LED bar to this block too. Okay, so now we have 10 meters of power, but we also need 10 meters of data. Or, well, we don't need it, but, you know, let's do that for this test. So here's another bundle of cable of about 10 meters. Oh. And let me spool that a little bit. So let's put this end in here. Okay. And then the other end goes into this yellow one in the middle here, let's say. And the data wire from the strip goes into this one too. Okay, So now we have 10 meters of wire connected between the Dig-Quad and the LED strip, which we were just running. And let's see what that does with our power usage. I mean, who knows, right? Where's pink LED guy when you need him? Yeah. I can simulate that, Jeff, but this live stream isn't about that right now. But actually, if you don't need 3-wire cable to do that, if you have 2-wire cable like I'm using here for the data, and I just hook up this end to ground, the data signal will be shot. So we don't even need 3-wire cable. But let's first see if this is working, because this is running next to PWM lines and AC lines and stuff like that. So I'm not even sure this will work. So let's see. Did I do something wrong? Huh. It's actually not working. Okay, what did I do? No, this should be pretty okay. Let me measure voltage that's actually going over the cable, if that's coming to the other end. Well, it could be voltage drop, but it's 10 meters, so I kind of suspected it to survive long enough. No, we're getting 5 volt at the end. So then it has to be a data issue somehow. It's in there. Oh wait, one of my meters is beeping at me. The controller doesn't actually seem to be online. Why is that? Is it shorting somewhere? You're right, the controller isn't starting. Wonder why. Let me disconnect this. It might be because the data wires are running over some AC wires and stuff like that. That's never a good plan. Oh, we can oscilloscope it, but... Okay, so now the controller is online. I think. Yeah, controller is now online. And the LED strips are showing massive amounts of corruption. So, I think the data wire is running next to something that is causing corruption. Which I already said was very well possible. Let me try and reroute that a little bit. How am I going to do that? Okay, let's take this one. Let's see here. Come on. Okay, let's move that over here. Okay, let's see if this works. Nope. Why not? What am I doing? Am I misinterpreting this block? Let's remove the data connection from this block. Let's see if that helps. I think the cable simply hates you. Yeah, looks like it. No, I think I'm just asking too much of it. Okay, well, that wasn't really part for this test. But, yeah, too long data cables can get you. So let's do a quick check and see if it'll work. If I connect the data cable directly, nah, my testing setup that I currently have really isn't ideal in regards to noise and stuff like that. So, okay, let's try this. Wait, that also doesn't work? Well, at least the controller came online. But the LEDs still don't work. What? Is it the multimeter that I spliced in? I mean, that shouldn't matter. Yeah, it's outputting on all pins. I don't understand. Did I break the bar when moving it just now? Could be. Okay, let's hook it back up the way it was. See if that helps. So let's hook it up directly to the board, like it was before. Power is off. Okay, let's turn it on. Huh, now it works. Jesus. Okay. Okay. Huh. Interesting test here. Well, this is my first time doing this test with this power supply, but I don't see how that would make too big of a difference. Let me reroute these power cords also away from all the AC stuff. And otherwise, I have a trick up my sleeve. Yeah, I'm also suspecting the connector block not working too well, so I'll use a different one. I actually have a trick up my sleeve which might make it work with a little bit more resistance like we're seeing. So let's disconnect the LEDs directly. And let's connect it. Let's connect the long cable. Okay, and then here we have the other end of the long cable. Let's connect that. And well, data is still directly connected. So now we've just extended the power. In theory, that shouldn't be too much of a problem. And it's not working. Why not? Oh, now it's... What? Okay. Ah, I think I might know why it's not working. Hold on. Let's move the power supply here a bit. I think I might know why it wasn't working. Hold on. Let me check. Now let's extend the data wire too. Oh, yeah, okay. Johnny's here. Nice. Yeah, we're not getting our pink LEDs to work, Johnny. Okay, so let's extend that signal again. Oh, and I can't show you the connection. Oh, I can. So here's that connection block again, but now I don't know which side is from what. Okay. Okay. Let's see what that does. No, wait. I have to put the ESP on the board. Otherwise it's not going to work. Okay. It's not happy. So this is what it looks like when your data signal isn't working correctly. It's somewhat working. So I can make it green, blue. Let me try an effect. Oh, actually that is working. But I think there's some kind of grounding issue going on because, as you can see, it's flashing all kinds of weird now. And now it's fine. Generally, that's a grounding issue. And I think we can actually fix that with a little board that I have upcoming. So I guess we're changing the stream content a little bit, and we're going to try that because, as I mentioned before to Jeff, I don't have this ground wire connected. If I connect it right now, it goes even more nuts. But let's disconnect it and let's connect a little something here. And that is my QuinLED data booster, because I can set that to 33 ohm and then run additional ground with the signal. And I'm wondering if that will clear it up. So let's test that. Yeah, I think the reason why it's flickering is because there's a lot of PWM going on in this room right now. And that is likely overwhelming the data signal. No, we're not using 24 volt yet. This was still on the 5 volt setup. So let's add my little data booster board here. Because if I use that one, I can run the ground next to the wire that has the data on it. Oh wow, this has been very badly crimped. Okay. Yes, it's getting, because it's a single-ended signal, It really isn't meant for the distances we're trying to make it go. And if it picks up any interference in the meantime, well, basically this happens. So now I can connect the grounding wire next to the data wire, because I can now change the output resistance, and then we should have created a little bit of a transmission line. And I'm wondering if that's going to be enough to fix this issue. Let's see. No. Damn it. It sucks. Okay, let me try one more thing, and otherwise we have to revise how we're doing this test. No, the booster shouldn't be at the other end, because I'm changing the impedance of the cable, or I'm trying to match it basically, because of the transmission line properties. Cool, catch you later, Andy. Okay. The stupid thing is, I have run hundreds of tests, but I know that it's likely my light's actually causing the issues right now. I can show you that, I guess. Hold on. Let me try and get these wires somewhat situated. Because those are a mess now too. Okay. Let's see if this works. And now it works. Yep. Oh wait, you can't see that, right? Okay, so by changing how the data signal is being transported a little bit, we've made it work. Well, Seth, that is actually a decent conclusion. The longer you make your data lines, the more issues you can run into. But what I now did to try and solve that is by running ground next to my data line, but that causes an issue because of transmission line effects, but it also kind of shields a little bit against interference. But then if we counteract the transmission line using a 33 ohm resistor instead of 249, 33 ohm, we kind of create a transmission line on purpose, which then shields against the PWM radiation and stuff like that I have in this room, and makes it work perfectly again. Because, okay, so you saw that I hooked up the extra ground. Let me, just for demonstration purposes, but there's more videos coming about this and this board. Let me disconnect this ground line. Oh, wait, I also connected it on this side. That's not fair. So I disconnect the ground, immediate issues. I connect it, issue solved. But I'm wondering now if I disconnect ground. Yeah. And then I switch it back to 249. Yeah, see, without the transmission line effect with the extra ground there, we're still having issues. But having the extra ground and connected on the back side and on the front side, well, it kind of solves those issues. No, actually, if you have long length data issues, having ground next to your data wire but then also having a resistor which is specifically tuned for that using this little data booster board, that can filter out some noise. That's basically what's going on. And I think I kind of know what's going on, which is causing the noise, and that's my lights, because those are all 24 volt PWM, and those will radiate PWM noise, and that noise is very near to the frequency that the LEDs run at. So that's why it's causing issues. Yes, you have to match the data line resistor. Oh, this is just some random aluminium profile I picked up from the hardware store a few years back. I use it to cool these strips. Anyway, as I said, there will be more content about LED data resistors and this little booster board in the future. But it's good that I can actually show that it, well, solves an issue right now. You know, which we otherwise wouldn't have been able to without resoldering some resistors. Okay, but we wanted to talk about voltage drop and maybe running a 24 volt network. Yeah, this is all beyond spec. Generally it should work, but as I said, I kind of know my lights cause some interference. And, well, right now it's just too much. Right, so if we measure the voltage for the LED strip, right now we're seeing a good 5 volt, even after that 10 meters of cable, so that's good. But what if we up the brightness? Okay, so we're now doing the Pride 2015. And you can already see that the voltage really started to drop. Although, if we look at our document, Pride 2015 only used 8 watts. So even that causes a voltage drop. Let's go to orange 100%. So let's go to solid and then WLED orange. So I'm seeing 13.5 watt draw from the power supply. That is about the same, it's a little bit less, but about the same as we saw before. But now we're only getting 4.5 volt to the LED strip. Yeah, Philip, data stuff is very difficult. I can make this 10 meters work too, also without the board. But likely I'll have to turn my lights off and they'll fix it. We can try that at the end of the stream. That's an interesting test. We'll run all the original wires and then I'll turn off my lights. And that's likely going to fix it. But I recently discovered that running the 33 ohm resistor and then having extra ground on purpose next to your data signal can actually help filter some of that out. But different video. I'm not in focus on it, am I? There we go. So, we're drawing about the same from the socket, but as you can see, we're only getting 4.5 volts at the end of this 10 meter or 32 feet cable. And if we take the amp meter and let's set it to amps, and let's measure what's going to the strip. No, wait, I have to zero it first. So now we're only seeing 0.86 amps going to the strip, while before we saw 1.7 amps going to the strip. So although our input power from the socket is about the same, this heap of cable that's now between it is causing so much loss that we've dropped to 4.5 volts, and our amps are less than half than they were before. So that is just to demonstrate the effect long cables have and voltage drop. Where 18 gauge from the board to the LED strip is fine, 10 meters of 18 gauge is causing a whole lot of drop. No, actually the QuinLED board design isn't changing because it's very situation dependent. And the resistor that's currently on the boards is there with a reason. But that's also part of the reason why I created this little board, so you can basically adapt the signal to your situation. But yeah, let's go to white, see what happens. Wow, okay. So we're currently drawing, oh wait, maybe I should write this stuff down, huh? 5 volt, 10 meter wire length. Orange 100% was 13.5 watt, and on the meter it was 0.8 amps. And now we're doing white 100%. We're not doing all the tests. And that is showing 30.5 watt on the socket and 2.37 amps on the meter. So because we're getting such insane voltage drop to 3.4 volts, the 6.15 amps went down to 2.37 amps. So this 18 gauge cable, even just for this little strip of 143 LEDs, although it's in forced RGBW mode, it still isn't enough. It's way too little copper to be able to handle this load. So 6 amps might be unrealistic, but then again, if we're talking 300 LEDs and 300 LEDs, so 600 in total, that middle injection there will do 6 to 8 amps during normal usage. So although this is a simulated load and not that realistic, it is a realistic load if you're doing a large LED install. And then if you're using 18 gauge cable, well, that's not going to suffice. I mean, the evidence is right here. We're only getting 1/3 of the load, and the LEDs are only getting 3.4 volts only. So that's barely functioning still. Okay, so I guess, well, this was meant to prove the point that running 5 volt injection cables, you either need really, really thick cables like, you know, like this guy, but that gets expensive real quick. Or you need to use shorter wires, but you can't in all situations. So let's see if we can use these converter blocks and see if that actually works and solves the issue of transporting the power to where it needs to go. And I'm turning this off because it's very bright. So after a little bit of a detour, I still hope the point is obvious. 18 gauge, which is a decent wire size, still isn't near enough to transport power for like 32 feet or even 16 feet, so 5 meters or, yeah. Okay. So, let's take our little setup here, and we just have to change the power supply and then add one of these at the end. And I'm going to think about how I'm going to do that. Okay, so let's first change the power supply. Okay. I'm going to just take a random... Well, I don't feel like disconnecting all the wires, so I'm just going to take a random 24 volts. Hold on. So I'll be using a Meanwell here. It's another Meanwell's different series, but yeah. So let me hook that up. This isn't going very streamlined today, is it? Welcome to my live streams, I guess. So we have plus and minus hooked up just like we had before. No, we're not going to blow some strips. Please don't. I just got these bars made. Okay. So let's run it real quick without power going to it. Because the board should auto-adapt, and this little board even should also auto-adapt. But let's put that to the test. Okay. This all looks good. Minus, and the input wires here are disconnected. Yeah, should be fine. Pew. Okay, so QuinLED is turning on. The data booster is also turning on. Yes, the data booster has been designed up to 48 volts. And let's see if WLED is online. Yes, it is. Okay, so far so good. That's a nice thing about these new boards. They auto-adapt to the voltage that's coming in, even to 24 volt. So, we now take our power wires, no smoke, and, well, let's adapt them to 5 volt. Should we start with the smallest converter and see if it can handle the load? I think that's fun. So that would be this one. This one's definitely the tiniest. Okay, so this side says input. So I guess I'll connect red here and black here. And then I take these red and black, connect those here, connect those here, and then we have the same on the other side, and those can go here. So blue for ground, and then yellow for, which should now be 5 volt. And, well, you can already see a downside. YouTube isn't stable today. Interesting. Let me check my stats again. Yeah, I'm still at 0 dropped frames and 0 network and 0 encoding or rendering lag. Not much I can do on my side, it seems. So, a downside you can already see, this is becoming a mess. But, yeah, you'll maybe have to hide it in a project box or something like that. Okay. Let's go to the main view. Yeah. I think this is okay. Yeah. Okay. Let's go. Okay. We have LEDs. Interesting. Does that just work? Let's get my amp meter here again, and I guess it should be on this one. Right. So let's compare that to what we had initially. 24 volt tiny 5A converter. We have to go to full power. Orange 100%. It's drawing 14.5 watt from the socket, so it's actually drawing more than it initially did. And the amp meter is showing 1.45, let's say. That's slightly lower than we saw with the direct short wire connection, but yeah, it's okay, I guess. Let's do flow. I don't know. Yeah, it's working fine. So flow 100%, 12.4 watt from the socket, and the amp meter is showing 1.17. Okay. Well, I guess let's go for broke, huh? 100% white. Yeah, let's see if we can handle it. In theory, it's above what it can handle. Oh. Okay, well, it's bright for sure. It's much brighter than it was last time with just a 5 volt. It's drawing 43.5 watt from the socket, and the amp meter is seeing 5.2 amps. Can you see the amp meter? Yes. Cool. Okay, let's splice the voltage meter in there too. Trying to make this somewhat work. Oh, it's outputting a stable 5 volt. Interesting. My setting, the settings on my side didn't really change, so not sure what's going on. I guess it's YouTube. Don't know. Cool. Okay, so as we can see here, the voltage we're seeing going to the LEDs is 5.1 volts and stable. That's actually pretty good. Yeah. Well, I imagine it's heating up. So far, it's not even lukewarm. Cool. So instead of measuring what's going to the LEDs, let's measure what's going to the data converter and then to the board. Yeah, because the cables only need to do 0.7 amps now. So that's a whole lot less than the 6 amps. But because it's 24 volt, well, it only has to transport a whole lot less. So, yeah, that works. Yeah, we'll leave it running for a little bit. It's getting warm, but it's not, like, hot. It's just a little bit warm. Sorry about that. Hold on. Can we use both 24 volt and 5 volt LEDs at the same time by using a step or a buck converter at the output? But that's basically what we're doing, Arun. We're doing everything 24 volt, and at the output it's being converted from 24 to 5 volt and then run to the LEDs. I could Flir the converter, but the converter is in a metal case, so that won't really work on the Flir. I could put some tape on it and then we could measure it, but it is getting warm. It's lukewarm right now. Yeah, you want Flir? Oh, okay. The problem is, if I put tape on it, I basically take away its ability to dissipate heat. Put the buck converter immediately before the converter? What? I'm confused. Okay, it's definitely warming up. Let me see if I have some paper tape. That should work best, I think. Yes, I do. But basically, I'm taping up a part of its heatsink, so taking away the ability to dissipate heat. But yeah, put pink tape on it. I don't have pink tape, It's an oversight on my part. I apologize. Okay, so to be able to use the Flir, I kind of have to take away the metallic surface. And let's see. Here it goes. Let me enhance that for you. So, currently it's... Oh, it's getting warm. It's at 52 degrees. Let's see what the black underside is. Oh, I think we can see where the... Ow. Okay, it's getting hot. I think we can see where the buck converter is actually located, if you see here. So this is 64. Ow, okay. The paper burns better too. Thanks, guys. My fingers are burning. But I'm actually pretty impressed by this 5 amp converter, because we are certainly asking 5 amps of it, as we saw from the clamp meter, and it's been doing that for, let's see, does it show how long it's been online? No. Oh, wait. Anyway, this is now 68 degrees. Yeah, I'm actually impressed that the 5 amp converter is converting 5 amp no issue. Yeah. That's pretty decent, actually. Okay. I think that's long enough for this converter, because we also have more converters. I don't think it's been 10 minutes yet. Can I see? No, I didn't take it into account. Okay. Get some eggs and have your dinner. Yeah, but I'm pretty impressed by this little converter. Ow. Yeah, it's warm now. Okay, let's turn that off. Because, well, I have multiple converters that I wanted to test. Do you recommend running cob LED along with RGBWs on Dig-Quad? That's a bit of a many questions. I'll check WLED uptime. That's a good one. I just turned it off. Damn it. Well, let's say it was a short 10 minutes. I think it was easily that. Okay, so I have a second 5 amp converter from the same, they're all from the same Aliexpress seller. So this XWST. Are we testing those cheap 12 volt car converters as well? What do you mean with that? Okay, let me hook this one up. So input. I have to make extra care here that I don't put 12 volt on my LEDs. But I think we're good. Output. Right. Let's try and get the clamp meter in here too. Somewhat. Okay. Let's try and show the actual thing. Okay. So this should... Oh wait, this is the minus line. That's not going to work. My camera screen is a bit overcrowded because of certain wire lengths. Okay. There. we'll make that work. Okay, so now we're testing this guy. Okay, LEDs still turn on, that's good. Let's just go to full white. Oh, wow. Oh, that's definitely more than the other one. Slight voltage drop, but I'd say 4.9 volts, okay? So it's drawing 43.01 watts from the socket. Now let's just say 43 watts. And the clamp meter is saying 6 amps. Oh wait, I'm not showing you the notepad. So before we had white 100% 43 watts and then 5.2 amps going to the LEDs. And this one is outputting 6 amps to the LEDs. So that's better. So I guess it's more efficient. No, we're okay with the field of view. Everything's in there. Oh, you had to ask, didn't you? How is the ultimate disc project? Well, I actually had an argument with my girlfriend about it today, so it's going great. I need to pick that up again. And the argument is about it taking up useless space. But yeah. Oh, it's recovering in voltage. Interesting. Yeah. The previous one was a 5 amp converter, but this is officially also a 5 amp converter, but it's outputting 6 amps. So I guess maybe the other one was current limited, where this one isn't current limited. Yeah, I'll get the Flir in a minute. I have to, have it running for a little bit. Oh, there's some hot... Oh, okay. Maybe I'll get the Flir now. There's some hot spots there. Yes. Okay. Let's see here. Can you see that? There's a very hot spot over here. That is 80 degrees. I know you can't really see on camera, but that little spot there is 80 degrees. Yes, asking 6 amps of this guy is probably not gonna give it a long life. The back side is 46 degrees. 84 degrees. My meters don't like being on this long. Okay, I didn't zero it, so that's not the correct value. See this little wire here? Oh, it's 40 degrees, that's okay. Uh-oh, it's now 89 degrees. This isn't looking too well for this little meter, or for this little converter here. Or rather, I liked the small one being current limited, but not overheating like I feel this one's going to. That's a better design than just drawing whatever. Let me turn this off until I can zero it. Yeah, but there's no cooling this because it's encased in plastic and resin. No smoke yet, but let's see what temperature it is. 91.5. Ah, okay, you have the same one, Irataro? Iratarto, yes. Joint late. Any smoke yet? Not yet. So let's see if it gets 100 degrees and then I'll turn it off. Oh, well, I guess we're there. Let's see here. 94.5. Yeah, well, I wouldn't want to run a converter that is 94.5 degrees at some point. That just means there isn't enough heat sinking. But then again, it's doing 6 amps. So, I mean, if you use it for 3 to 4 amps, it's likely fine. But right now, it's just being over-asked. No, I don't want to pour water on it. Although it's water sealed, but yeah. What I want to do is turn it off. And connect the 10 amp version of the same thing. And again, if you're doing a middle type style of injection, so let's say you have 600 LEDs. Oh wow, look at the 10 amp version versus the 5 amp version. The wire thickness is definitely different. Can you see that? It's easily twice as thick. So the 5 amp version has, does it say? Yeah, well, it's easily twice as thick. So let me, no, well, if you're talking a middle type of injection, this is a nominal load. 5 to 6 amps is not that much if you're running 5 volt LEDs and it's in the middle of the strip, basically. Or in the middle of 2 strips, I'd say. But that's exactly where you'd want to use this thing. So it's a tea maker? What? Oh yeah, I guess. Okay, let's zero this one. Okay. And let's put it on here. Yeah, I guess that should still all work, right? Oh, wow. This one's outputting 5.2 volts. It's a bit high. It's okay. It's on the high side. It's still okay. That's generally within spec. Okay. Let's go to 100%. Let's just do immediate 100% white. Okay, dropped a little bit in voltage. Let's say plastic 10 amp converter. White 100% is doing 41.36 watt from the socket, so that's actually a little bit less. But on the clamp meter, it's showing 6. Let's give it 6.1. Cool, and it's outputting a little bit higher voltage. So higher voltage combined with higher amperage is, well, a lot more power for your LEDs. So this is definitely, in my opinion, a different converter than in the other block. Although visually they might look the same. I mean, just even these cables here. See that? That's a massive difference. So please make a video about blowing up or power using converters above their specs. I'll watch that every time. Maybe at some point. Use some protection. Yeah. Yeah, exactly, Air Cookie. So this one, it looks to be more efficient and thus is losing less heat in, or losing less energy or power in heat. so far. Oh, let's leave it running for a few minutes again. I don't believe there was a too big difference in price between the 5 amp and the 10 amp one. We can take a quick look at that while this is heating up. And let's get the link for that. Plastic housing. So the links should be in the description. Let's see if my Chrome scene works. Right. So we have the, this is a 1 amp one, 2 amp, 3 amp, 5 amp, 8 amp, 10 amp. Okay. Right. So the 10 amp one is $6.40, and then it adds some shipping. Oh yeah, and then shipping. Oh, okay. If you buy 4, the shipping is less than just adding up. But the 5 amp one was, yeah, so $5.19 or $6.40. I'd always get the 10 amp one because that's already doing a lot better. And did they have another variant? No, okay. So that's the biggest, the highest amperage variant they have in a plastic form factor. It says 96% efficiency. Might be something there. Might actually be a true claim. Interesting. Well, of course, yeah, but I mean, since the case was the same, that's why I ordered them both. Sometimes the internals are the same too. And while this being Chinesium power, you know, you're never 100% certain that what they claim it'll actually be able to do. But so far, well, the two we looked at, so the little metal one and the little plastic one, they're spot on in regards to specs. And I mean, I even if I bought a power supply here in the Netherlands, I still wouldn't run it at a 100%. So if you stay like at 75-80%, that's likely going to be fine. Yeah, let's take a look. It's been running for a few minutes. Oh no, did you guys see my unlock password? I doxed my unlock password. No. Let's wait for the Flir to wake up. There we go. Let's see here. 34, 34, 41, 40, 40. Okay, let's see on the sides a little bit. Oh wait, you can't see it. There we go. So there's a little hotspot here. 43, 44, 46. Oh, there's a chip there. 50 degrees. Yep, 50 degrees. That's fine. Nothing here. Yeah, so the hottest spot on this one is 50 degrees, while the other one had already reached like 80 or 90 degrees at this point. Cool, okay. That is pretty good. Well, voltage is pretty stable and good too. And the amps, 6.1 amp, that's still doing well. Yeah, I like it. Yeah. And well, if we look what is actually going to the converter, we're seeing 1.36 amps because, well, that is 24 volt, and the 6 amps is at 5 volt. But now the 5 volt cables are very short, so that's no longer a problem. And while these are 18 gauge cables, and they can transport 1.34 or 1.4 amps over the 10 meters or 32 feet we're currently doing. So it's going to be the question of, can I hide these extra wires where I want to make injection points? And then how much would really thick cable be? You know, like a 12 gauge like we looked at that we needed, versus buying a little converter and then using 20 or 18 gauge cable. We're using 18 gauge today to go to the LEDs. I mean, yeah. 20 amps or bust! Well, I can hook up another bar. You want me to hook up another bar and see if this one can actually do 10 amps? Sure, let's do that. Because we've kind of already proven the point. So I kind of halfly prepared that we would be able to do this. Let me turn my Flir off real quick. That's just, what? Yeah, I'm not going to break them open. These are fully potted devices. So that's at least not going to happen today. But what I am going to do is add another bar. See what it does. Probably be blind at the end of the stream. But in theory, we should be able to... Oh, I can't... Okay, I need to unhook my voltage meter from this side at least. Right. Yes, more fire. All the... Yeah, the fire extinguisher is still in its spot. Okay. And then we're just going to duplicate the data wire, so that's easy. Okay, I don't have a spot for my voltage meter right now. Well, I guess I could just use ground. Yeah, that's not a good ground. Okay, let me remove this real quick, and let's get the clamp meter back. Oh, the bar is hot. Where did I put my clamp meter? It's gone. No, it's not. Maybe it is. What? Oh, wait, here it is. Jesus. Right, so... Okay. And I'll clamp it on the line going to the board. No. I'll clamp it on the converter. Duh. Right. Okay. Yeah. Pink wires for you, man. Hey. Always. Yes. Okay, you can't see it. Maybe you can. Now we have 2 orange bars. Okay. We're doing 1.88 amps. No, yeah, 1.88. And we're looking at 14.7 drawn from the socket. Let's immediately go for broke. Let's go for white 50%. That is asking 42 watts from the socket or 6.3 watts from the converter, which you can't see anymore. There we go. And now let's go full power. Okay, we're asking 84 watts from the socket. I'm going blind. And let's see here. The meter is showing 12.18 amps. Oh, no. Are we going to get fired this stream instead of the previous one? Who knows? Okay. Yeah, let me move these bars because they're shining right in my face. Oh, so much better. It doesn't want to do that. But I need it to do that anyway. Okay. Come on. There we go. Okay. Well, we're doing the 12 amp on a 10 amp converter test. That's always good. Yeah, you can't say I'm not a people pleaser. 48 volt to 12, yeah. So you can go 48, of course. The reason I'm using 24 volt is because then I don't have to do anything with the current QuinLED pre-assembled boards, because those can take 24 volt in natively. So we're just feeding it 24 volt from the power supply, and I can still use the power distribution, diffusing, 5 volt EXT function if you want to, level shifters, all that stuff still works. So, and 24 volt is already a very big improvement over 5 volts, basically. Now let's, you know, or you just want to see it overheat? Oh, it's definitely getting warmer now. Sure, well, let's give it a minute. Let's give it a minute. Oh, my bars are getting warm too. Yeah. Burn, baby, burn, says Philip for €5. Thanks, Philip. That's appreciated. Yeah, we're still at 83 watts from the socket. Oh no, I touched it. Sorry, I misclicked. Yeah, no problem, no problem. Oh no, one of my meters is thinking of turning off again. There we go. Oh. I guess that decalibrated it, damn it. There we go. Okay. I do wonder what our voltage is right now. Let's see if we can check that somehow. The power supply is turning on its fan. Let's see. This isn't the right ground. Where can I get a ground? Where can I get a ground? Oh, is there a test point here? Yes! Oh, I like these blocks. Those little three dots there are actually test points. Oh, I like that. I like that. Yes! Oh, okay, meter doesn't like it, but... So, even doing 12 amps, it's still providing 5.1 volts. That's pretty good. I'm running 12 volt for most of my pixels and 24 volt for distribution. I also use a couple of 3 amp 5 volt converters on smaller props. Yeah, well, these are worst case scenario tests, of course. I mean, we're currently doing 12 amps through this poor little converter here, which is getting really warm. Ow, ow, okay. Oh, don't worry about spam, Marco. We're all here to have fun. Yeah, that was one test I was intending to do. But I'm not sure how I'd hook that up right now. I'd have to change the whole setup. I'll think about it. How long have we been going? We've already been going 2 hours. Okay, well, I don't know yet. Okay, so voltage is pretty stable too. That's good. Let's see how warm it's gotten by now. So, normally you wouldn't need this tiny board in this current setup, but we were having data issues, And basically that is because of some EMI interference I know I have in this room because of PWMing LEDs and stuff like that at a frequency that's very close to the frequency of the data signal. So what we're currently doing, we're running an extra ground line next to the data signal, and then we're using this little board to change the LED data resistor to allow for that extra ground line, and that's giving us a clear enough data signal to test right now, where without it we couldn't do that. But there will be more videos about that in the future. So let's see here. The wire we're measuring is, ow, LED bar's hot. 36, 37 degrees. That's not bad. Okay, so this one, oh no, sorry, you can't see it. Nope, still not. There we go. So this one is showing a hotspot over here, and that is 78 degrees right now, 79. Let's see on the side. Ow, that's burning my finger. Okay, that's 84, 86, 87 degrees. And then on this side, 90. Yeah, 90, 90.4, 91. Okay, and then on the bottom side, well, we can see where the hotspot is. That is 103 degrees. Yeah, so asking 12 amps from this 10 amp converter for a prolonged period, because it's still doing 12 amps, and, well, the voltage, let's see real quick, 5.14 volt. So it's a little champ, and I'm going to turn it off now because I don't want it actually to burn. Yeah. Oh, Arun Ankam, 400. I don't know what currency that is, but I thank you very much. Awesome. Yeah, exactly, Cookie. That's my thinking too. If you design this for something that's generally running at 6 amps or 7 amps, this converter is going to be fine, I think. But then if there's a peak load up to like 10 or 11 amps, voltage stays fine, and it seems to be handling that without a real issue. Cool. So we had one converter left. And I think we'll test that right now instead of testing multiple converters down the line. We might have to move that a live stream up, so to test that another day. Okay, so yeah, I like this one. These converters are, I mean, come on. This one is a bit bigger, right? Let's see here. Output is yellow. And then plus and minus. Well, this will likely work, but you know. Okay. Let's try and get this into the picture somehow. Sure. Let's do that. Looks good. Do it. We have orange light. Let's immediately go to white and to full power. Okay, we're drawing 80.4 watts from the socket. Let's write that into a little document here. Metal 50A converter, white 100%. Oh wait, that's with 2 bars. Wait, hold on. Okay, 41. Yeah, 41 watts. Okay, and 6.12 amps. Okay, so the metal one and the plastic one seem to be doing about the same. Yeah. Okay. Let me plug that back in again to give it some load. There we go. And now it's doing 80 watts and 12 amps. Yeah. Oh, Accuracy says, this exact converter I use in the family caravan, only for 200 LEDs though. Yeah, I mean, this is 2 bars of 143, of course, but I'm cheating by using RGBW at full output. Normal LEDs or any scenario basically wouldn't use this much power. So the amps we're actually doing is much more important than the amount of actual LEDs we have today. Yeah, so data resistors we're going to be talking about more in the future. For instance, this is now at 33 ohm. If I switch this to 249, well, you're not going to see anything because let's show a little effect. Yeah, that's not looking right. You see all those flashes and stuff like that? That's with a 249 resistor, but that's very specific on the current situation. And if I use my little board here to change the resistor to 33 ohm, for the situation we've created here, that's now perfect. But we'll talk about that more in the future. Is 5 volt 40 amp safe to split over 3 pairs of 18 gauge? It might be, but how long are those cables? Yeah. Yeah, that's exactly the point why we're now using a 24 volt power supply while using 5 volt LEDs, and then at the end where you're doing your injections to the LED strip, you use a converter like this to step it down from 24 volt or maybe 22 volt or whatever is left of it after your cables to 5 volt, and you'll always have a perfect 5 volt at your cables. Oh, let's see what voltage this converter is giving off. Okay, that's a very nice 5.1 volt. That's very tidy. Yeah, Eric Cookie makes a great point again. If you're using these converters, maybe you have a 19 volt laptop supply somewhere, or some other 12 volt or 24 volt or well, depending on what the converter supports, power supply laying around, and then you can still use that for your 5 volt LEDs. Yeah, but 5.1 is very nicely regulated. 3 meters. That might be a bit much for 3 times 18 gauge. You would get some voltage drop over that from 40 amps. I don't think it'll burn, but they'll certainly become warm. Okay, well, we've been running this for a little while now. Let's see if we can find any heat. Nope. Yeah, I don't. I mean, I can't Flir this thing because it's metal. I could put a piece of tape on it, but there's no warm part I can even feel here. So that's probably going to take a whole lot longer because of this massive heatsink. Oh, well, we can look at that. Let's see here. Metal. So in general, I think these metal ones will always be more suited than the plastic ones. So the plastic ones, even the 10 amp one, was $6.40. And here you can see they have a lot of different variants. Again, plastic 5 amps. Oh, this one's actually more expensive. Interesting. Oh, here's the 5 amp aluminium one we looked at first. That is about $10. Oh, and this one has free shipping. Okay, yeah, that makes sense. And what's this one? 3 amps. Okay, so they have a 10 amp aluminium one. They have a 15 amp aluminium one, which is the one we're currently testing. And then you can step that up to 20 amp, 30 amp, and 40 amp even. But remember, you can only inject so many amps into one spot of an LED strip. So even the 15 amps is kind of overkill, because even if you have 2 times 300 LEDs and you're in the middle of that, at most you'll inject maybe 8 to 10 amps at peak, and really nothing more than that, because the strip can't take in more power at that point. You'll have to inject at multiple points to basically feed that power into the strip. But then you could maybe take like a few of those 5 amp or 10 amp plastic ones and feed those at the edges of the strip, and then take one of this 15 amp one and do that in the middle, so you have a little bit of overhead on all of them basically. But yeah, 40 amps is expensive, but you really won't need that. The 10 amp or the 15 amp don't really differ that much, so I just get the 15 amp. That's performing like a champ here, because it's still doing 12 amps, no problem. And yeah. Yeah, that's why we introduced the V2. Philip's correct. The V2 basically has all the features of the V1. There are some pin changes, but the features are the same, and it introduces additional features versus the V1, especially in its pre-assembled form. So yes, you could run Ethernet together with audio reactive, but then again, if you're going to be running audio reactive, what are you going to be using the Ethernet for? You have to ask that yourself, of course, but yeah. Because if you have Ethernet, you could also use LED effects or X lights or something like that. That would generally be the use case for Ethernet. But if you're just doing audio reactive, that's all done on the board. So maybe Wi-Fi for those is fine. But I mean, I don't mind you getting an Ethernet version, but yeah. Yeah, we're not going to be doing the multiple injectors in series today. I think that's going to be another live stream, because we're already 2 hours and 20 minutes in, so don't want to make it too long. Yeah, that's working fine. Let's see if the yellow wire is warm. Maybe 1 or 2 degrees. How hot is the quad and the fuse? Well, not very hot, because the quad is getting... can you see that? Yeah, 2.83 amps. So the fuse is also only getting 2.83 amps. So that's not a lot. So the fuse is fine. Because that's 24 volts, and only after this guy does it become 5 volts. And yeah, this still, I can feel that it's heated up maybe a little bit, but nothing really to speak about. Oh yeah, and the quad was fine. And this is still that one OZ quad with 40 amps. I'm not worried about my power designs. That's very much over-engineered versus what I state that it can handle. Cool. Okay. Ow. I burnt my finger on the LED bar. Okay, let's turn this off. This works. Oh yeah, there was one thing I wanted to try. We now use this little setup here with the little board to convert to a different resistor and stuff like that. Let's remove that again. And remove the second bar and remove all those things. And because I think once I turn off my lights, it'll just work. So let's test that. I'm just going to disconnect everything right now. And then reconnect it, and that'll be the last test of the day. Okay. Yeah, we can keep this one. Okay, let's... Ow, 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 hot, hot, hot. Okay. Oh man, even with that thick aluminium bar, this amount of power, it just gets so warm. So let's put the data in the middle. There we go. And then let's do power. Okay, and then this should be data. Right, okay, and then I should disconnect this one. Drop your voltage. Thank you, Chris. I wasn't thinking that, but you are very correct. Thank you. I would have blown up these LEDs for sure. Wow, I wasn't really thinking about that. You, sir, just saved me some LEDs. Okay, let's get the other power supply back. Yeah, exactly, Erkaki. If you're mixing PWM, especially at the frequency I'm running it at here, and data signals close, yeah, that's just not a good mix. You can do it at lower frequencies. That works fine. So I'm just hooking up the power supply. Okay, so we have our 5-volt power supply back. We have our little LED bar here, and it's just connected directly. And this little board is still in place. I'll keep it set to the 33 ohm. That won't work, but then I'll switch it to 249, and then I'll probably turn my lights off, and you'll see that that has a big effect. So let's turn it on. Okay, the LED bar is confused. As you can see, even set to a solid color, it doesn't know what to do, and it's just spewing out nonsense. So now let's disable the lights in my studio, especially the ones closest. No, not enough yet. Oh, right, we're still at 33 ohm. Let's go to 249. And there we go. Yep, that fixed it. So this is a clear case where interference on the LED signal. So we're still hooked up with the 10 meters of power cable and 10 meters of data cable, right? And we're running the 249 resistor mode instead of the 33 we were running before, because we've basically changed the setup. But now watch what happens. So the LEDs are working fine. 32 feet of cable, 10 meter of cable, both for data and power. And watch what happens when I turn my lights back on. And the flickering starts occurring. So that is because of the PWM from the analog LEDs basically interfering with the... let's turn all the lights back on. Basically interfering with the LED data signal. And as you can see now, it's basically become... well, it's somewhat unstable. It's vaguely working. But yeah, you don't want any flickering. But that's basically the problem. If you run your data wires next to a source of interference, yeah, that can happen because it's a single-ended signal and it's not very adept at resisting interference, basically. So let me change the effect, for instance, to something, I believe palette shows it pretty well. Of course, now it's working just fine. Yeah, let's take the little board. Oh, okay. And now it's not. Oh, of course, it was working because I was holding it. So, flicker, flicker. And now I'm holding it and it's fine. I don't know why that is. Maybe some extra grounding again, like I talked about before. But now it's flickering like crazy. And then I turn off the lights in my studio. And it's fine. So... that's a direct case where there is interference that is causing these issues. See that? Yeah, it's not liking those lights. But I know why that is. I kind of caused that myself in this case. But yeah. Yep. Would running data lines through shielded cable help? Yes, because that's basically what I did with adding the ground. So basically, if I add this ground here, using the 249 resistor, it's going completely insane. But if I then switch this board, okay, it's still not clearing it up completely. And that is because the ground on this side is still disconnected, but I don't have a extra ground connection on this side. If I was able to connect the ground on this side too, that would basically counteract the interference a little bit, like a shielded cable would do, with having ground around it and then having the signal run through it. You don't actually have to have the shield fully around it to have an effect on that. It's called a transmission line. So yeah, well, maybe I could add it to the ground here. Well, no, okay, no, it needs to be the ground, oh, maybe at 249. No, it needs to be the ground on the other side, so it needs to be the ground on this side, but I can't, okay, let me do that real quick, Jesus. I'm annoying myself. And there we go. So by adding a ground wire next to the data wire, having this one set to 33 ohm because 249 now doesn't work, but 33 ohm, and having ground added at the front and the back of the data wire, kind of creating a sort of shield around it, that makes it work perfectly again. different videos. Would twisting data and ground together help? Yes, but in the same way that just having the ground cable there helps. So twisting it doesn't really add that much in this case. It's not a differential signal. It's still a single-ended signal. But we're using an effect called transmission line to basically shield the data wire somewhat, to have it survive the PWM noise that's going around in my office, basically. So yeah, now it's working perfectly. But if I disconnect those grounds, it then again doesn't work. Or if I use a 249 resistor, it also doesn't work. But yeah, there will be more about this in the future. And that is basically the reason I've created this little board. So yeah. Okay. Let's turn this guy off and go to the face cam. So, that was a little bit of a messy live stream today with lots of different subjects I didn't really prepare on doing, but we kind of needed. But in this case, the interference source is also clear because we just demonstrated that. And, well, that is one of the things you can always run into during an actual LED setup. And, well, I just like having more options to deal with those. Just like this little board, which will be released in the coming weeks, which can help you solve some of those situations. Or, for instance, when you're doing Christmas props and you're using X-Connect cables or other 3-wire type cables, you'll also want either to change the resistors on the board or to use this little board to flip between the resistors, and then you'll be able to run much longer data cables than you were before. So, teaser time, huh? Okay, sure. We can do that. Let me get this out. Okay, let me clear my table a little bit. Will it be DIY? No. This will be SMD. It's SMD only to start with. And for now, I'm just thinking about selling it, but it won't be expensive. I'm thinking it'll be $3.49 a piece. So I would only use it if you need it for a specific setup or to solve a specific problem, really. Yeah. Oh, don't go yet. I just need to disconnect some cables here. Okay. Oh, you're putting up Permatrack this weekend. Awesome. Yes, there is already a shipment of these data boosters on the way to Dr. Z's too. So once the content about them comes out, they should also be available both in Worldwide and at Dr. Z's. And if you're doing Christmas setups, you'll want to pay attention to that content. Right, so teaser time, and I've been keeping this little board a secret for a while now, and well, it currently still has its prototype name called, and this isn't the latest revision, but this is one I'm willing to share. This is called a QuinLED-Dig-to-Go, or rather Dig-to-Go, because it wasn't meant to come out under the QuinLED brand, but we're maybe changing that. And what this is a little board that takes in USB-C and outputs LED. So you can take a generic string of LED strip, 5 volt, and take a 5 volt power supply and just hook up the USB and the LED strip works. And I need to see if this logged into my network. I think so. 10.24.1.1.2. And now we can just, have it do all kinds of fancy effects. Just like that. So this is a fully featured ESP32 WLED controller that can do 3 to 3.5 amps over USB-C from any generic USB power supply, which just has a single JST output connector that you can hook up directly to your LED strips and make it work. Now, of course, it won't have the giant amount of power like my other boards have, but if you just want to simply run 150, 300 LEDs, current prototype name is Dig-to-Go. But even 3 amps at 5 volt, because that's what your USB power supply also delivers, and 3 to 3.5 amps if you have a good one, which I happen to have been testing. Well, this doesn't look bad at all. So it's not going to be as super bright as, you know, a Dig-Uno or whatever could be able to get it with power injection and stuff like that. But if you're just looking to have a properly made board with protections, because this little guy over here is a 3.5 amp PDC, so there's a fuse on there that auto trips if something short circuits on the LED strip and then resets itself once that short circuit is gone. There's a level shifter on there. There's a bunch of capacitance on there to make sure the LEDs remain stable and stuff like that. I was working on getting infrared on there, but I might skip that feature, and I'm currently prototyping a version which has a digital microphone on there, and it has everything you want, like a USB to serial, auto programming circuit, stuff like that. So it's basically a fully featured ESP32 board, but then meant for small LED installs. And I've even broken out some pins like 3.3 volts, ground, 5 volt ground, A0 if you want to add audio, 3 GPIOs for adding whatever other stuff you might think of. And it comes with this little cable to which you can just directly connect your LEDs. So this plan has been, this board has already kind of been finished for about a year now. But initially, I didn't want to bring it out under the QuinLED brand because there's nothing DIY about this one. And I wanted to bring it out with a nice little case. But then I got lost into the Chinese injection molding plastic saga. Yeah, we're kind of still stuck there. So, what do you guys think? Would you be interested in a little board like this without a case? You can, of course, 3D print a case. I mean, or just wrap it in heat shrink, or I don't know. You can do lots of things with it, but would you be interested in a little board like this instead of, you know, for smaller installs, like instead of a Dig-Uno, even without a case? Well, you mentioned viral LEDs. This is my idea of a good, simple controller people can use. And there is no half an amp limit in WLED. There is actually hardware protection preventing you from using too many amps. And then you can put the software at 3, 4 amps, whatever. That's fine as long as your power supply is able to deliver that. Just get some generic tub and make holes in it. Yeah, but then the nice USB-C plug and this... Yep, this works perfectly using a power bank, absolutely. Even smaller form factor, that would be more expensive for me to make at this point. But this isn't big. I mean, this is my thumb. It's not a big board if you're thinking that. It's not available with mini USB. This can only work with USB-C. I'm ready. Take my money. I would buy 3. Okay. Throws money your way. Okay, that's a good response. Yeah, it just sucks. I mean, I've had this board done since November last year. But I've just been stuck in, yeah, in design hell. Or in plastic hell, I guess. Yeah. Technically, it's perfect, so... Yeah, I'm thinking of release... If I release a version, it would have a digital microphone on the board itself. Yes. Yeah, this is exactly for those kind of projects, Tech Turtle. It's a very low power. It doesn't use much power at all. And it's perfectly suited for power banks, random chargers, whatever. I mean, even running this effect right now, it's using about 1 amp. And this is 300 LEDs. These are eco LEDs, but still, I mean, yeah. You could easily run that for hours off a power bank. That's no problem. Okay, then I'll think about releasing it this year still. I'm not too sure. 3D design, actually, we have a case design. We're just stuck on plastics and stuff like that. But if you think it's useful without a case around it, I'll think about releasing it. And yeah, I'd release it with a microphone. I think that's good added value. Yeah. If the price is right. That's a... Okay, open question then. What would you be willing to pay for such a board? Shut up, take my money! Thanks, Philip. I got projects for it now. That's awesome. Yeah, so USB PD is definitely a thing. This current version is 5 volt only. I might do a PD version in the future, but that's currently out of scope. Okay, €20, 15 to $20. Okay. Oh, 20 to 25. Okay. Take my money. Just perfect for ambient lighting. Yeah, oh, that's absolutely correct. If you want to run luciferin or something on it, it has the USB serial chip on board. And it can handle 3 to 3.5 amps of power if you can get it into the board, because not a lot of chargers do that. But 2 amps or 2.5 amps generally is fine. Yeah, absolutely. Then you can do luciferin directly over USB, no problem. 20 sounds good. I would even buy one for 50. Yeah, no, it's not going to be 50. My target would also be between $15 and $20. So let's see if I can make that. $18.99. Even without a case. Okay. So yeah, the only reason I've been keeping this project back is because I just didn't have a case for it. And we kind of got stuck on that problem. But if you guys don't mind, I'll make a batch. I've actually been thinking about that, of maybe making a 3D printable case and then having a pre-printed option available, basically. But I'm not sure people would... I wasn't sure about what people would think about the quality if they got a 3D printed case, basically. 15 to 20 is about the same as the ESP32 cam. Okay. You want even more close-up? No, this is close enough. I don't need people reverse engineering the circuit. That's settled then. What's the next sneak peek? I'm quickly running out of sneak peeks here because, well, at some point there's not even projects I've been working on. Yeah, Air Cookie, I mean, I thought, okay, I have enough experience now in producing this kind of stuff. let's take the next step and make a nice plastic case for a nicely encased product. Oh man. Would you need a full-blown ESP32 on there? Why could you not do with a smaller ESP version? Well, currently software support is only ESP8266 and ESP32. I don't want to use an ESP8266. I know the C3 and stuff like that is coming out, and also with support within WLED and I believe the S2. But then I'd really just rather use the fat ESP32 on there for like $50 more. I mean, yeah. Make a big batch. We'll see. We'll see. We could design a case with heat inserts. That would maybe make it more... heat inserts? Missed the show. What's that? Says Charlie L. This is the sneak peek. So you arrived just at the end. And this is a little board that takes USB-C power. And then you can hook it up directly to a USB strip. And, well, it won't run full power. It'll still definitely display some really nice effects. Yeah, well, exactly like Air Cookie is saying, I'd rather pay 50 cents more, which likely is the difference, and have a full fat ESP32 on there. So, yeah. How much for this one right now? What? You're not getting my prototype. I'll try and make that happen, Arun. I'll really try for that. China's currently going into vacations and other stuff, so I have to see if I can squeeze it in between Dig-Uno and Dig-Quad runs, but I'll try. Put it in a big wrap like Chinese controller. Oh, you mean like a heat shrink? Yeah, you could easily get a heat shrink that fits over here and shrink it. Sure. Yeah, no problem. And there's nothing on here that would get too hot either, because I designed the hell out of it. And that's going to be fine, trust me. Question, Quinled, any way to make them with different connector than JST? That's my only problem with it. What's your only problem with it? All LED strips come with this connector. I mean... but yeah, you could make a custom cable, because I just have a JST connector on here. It's a slightly different one, but you'll get a converter cable from this one to that one. But this is a manual cable, so you could just make your own cable to whatever other connector you like. Yeah, yeah, but that's the problem. I have a lot of stuff to work on, including what you just mentioned, the updating the DIY boards and stuff like that. There's a lot of stuff going on. Also behind the scenes, like as I said, I've had this controller for a year now, and there's a lot of time and design work that went into it, and testing and all kinds of crap, and this is the first time I'm showing it, so there is lots of stuff going on. How soon will this ship? I'll at least need to do one more prototype with a little change I want to do, and then we'll see. I won't need the connector and the cable all the time. Okay, yeah, but that's why it's a disconnectable cable. You can use whatever cable or connector at the other end that you want to. It's not really designed for having long cables after the controllers and stuff like that. It's really designed for, you know, like the viral LED guys are doing, having a controller you basically plug into the LED strip and then a USB-C cable that goes to there. There is no beta program, sorry. Yeah, you can make an X-Connect or a Ray-style cable, etc., but this is only 5 volts, so pixels and stuff like that might be a bit of a bigger challenge. And again, it's not meant for having a large data cable and lots of amps and all that other stuff we've been doing today, that's what the Dig-Uno and Dig-Quads are for. This is like, I have 100 to 300 LEDs, which don't need to be max brightness. I just want a little controller there, and you know, I want to put it in my kid's room, or I want to put it in a cupboard somewhere, whatever. I just want to use a little charger there, or a power supply, and hook it up using USB-C. That's what this is for. If you want anything else, longer data cables, 12 volt, 24 volt, whatever, that's what the current boards are for. Yeah, Chris, I have plenty of ideas. Don't worry about that. My Christmas tree setup would be perfect for this board. Sure, yeah. It depends on how many LEDs you have in there, but yeah, for sure. You see, well, but actually, that's just the thing. Those fairy lights you need to inject after three strings. This controller is not suited if you need to do any type of injection, because it can deliver the 3 to 3.5 amps to the first connection already. So having multiple connections doesn't make sense because there isn't more power. Do you understand? So then get a Dig-Uno or Dig-Quad. That's what those are for. Do you ever design something not for LEDs? Actually, I do. But I have a plan, and I haven't shared much about that yet. But currently the code name for that plan is Plan Next Year. Not sure when next year, but we'll see. And then we'll be doing a bit more stuff that doesn't directly involve LEDs. But yeah. 200 of those fairy lights. Yeah, you'd get voltage drop at the end. I don't recommend running more than 3 strings without injecting each side, but yeah. No, there is no sneak peek 2. This was already a really big one, because, well, I've been holding back on sharing this one for a year now. I mean, I had the first working prototype in November last year. So, yeah. No Quinn underwear. What? No, this is going the wrong way. Oh yeah, 50 or 100, that will be fine with this board. But as soon as you need injection, this board isn't the right board. That's basically it. So if you just want to, you know, my daughter wants a LED strip in her bedroom, and you also think viral LEDs are giant rip-offs, that's what this is for. No, the data booster, I've sneak peeked before. That's not new for today. It's new that it's been produced and it's almost here, but it's not new for today. Quinware. Maybe. If I hit 1 million YouTube subscribers, I'll make Quinware. Sure, no problem, Mo. I love sharing stuff, just sometimes I need to keep stuff back. Yeah, but Philip, if there's only 3 amps, and you can input 3 amps into a single injection, what are you going to inject with? Unless you're trying to fix voltage drop, but... I agree that my day job is taking too much time from my projects, Draadstal. And we'll have a talk about that soon too. Would that board be out before Christmas? I'll see if I can make that work. Okay, guys, I thank you a lot for hanging out today. We did a lot of experimenting. Didn't go as straightforward as I wanted it to go, but in the end, we made it work, even with my little data booster board here. which there will be more content coming up soon, and they will actually be available. And in the end, we were able to test the 24 volt versus the 5 volt, and we saw that we can definitely get about the same amount of amps being used using some of the converters. So the LEDs would have the same power, but then we can use much shorter, much thinner cables than we were able to do without using the 24 volt, and thus save a lot in cable, or cable hassle actually, and also in money probably in the end if you're doing a really big project. At some other point we'll look into if you're running 600 or 900 LEDs and you want to run multiple of these boosters. Let me actually show you. I did actually prepare for that because this is another 3 of those 15 amp units. What would happen if you'd run multiple of those boosters over those 900 LEDs, let's say, and can you create a 24 volt distribution network and 5 volt LEDs? So that will be for another day. Thank you all for watching, and yeah, I hope to see you guys back on the Discord server in the video comments on another video, or maybe the next live stream. There's probably not going to be a live stream next week. I'm trying to make that a video, but we'll see what happens. Okay. Talk to you guys soon. Bye-bye.